Welcome, everyone. Look, the AI landscape is literally shifting right under our feet, and the roles we play in tech are evolving faster than ever before. So in this explainer, we're going to walk through the definitive, step-by-step roadmap to mastering the booming field of AI engineering by the time we hit 2026. We are taking raw data, industry trends, and the exact curriculum that thousands are using right now and transforming all of that into a clear, actionable journey so you can master this field. And just to put things in perspective, over 20,290. That is how many developers are already actively tracking their progress on the exact roadmap we're exploring today. Crazy, right? This isn't just some theoretical idea. It's a massive shift in the industry. Developers are actively pivoting, and this explainer is basically your map to joining them right at the forefront of this new frontier.
Okay, let's just dive right into it. Our game plan is broken down into 5 distinct phases. We'll start off by defining the new AI engineer, move right into mastering prompt engineering, explore memory with vectors and RAG, step into action by building AI agents, and finally, we'll wrap up by looking at multimodal AI and safety.
So let's kick things off with phase 1, the new AI engineer, and really defining our ultimate destination here. There is this massive misconception floating around the tech world right now that you need a PhD in advanced mathematics just to work in AI. But we've got to bust that myth right out of the gate. A machine learning engineer? Yeah, they're in the lab developing entirely new models from scratch and advancing AI theory. But the AI engineer, that is the builder. Your job isn't to build the engine from scratch. Your job is to take the most powerful engines ever created and build the car. It's highly practical work, It focuses on product development, front end, back end, and really seamless full stack integration to drastically improve user experiences. Moving right along to phase 2, mastering prompt engineering. This is absolutely your foundational skill. The crucial point here is that before you can build complex systems, you have to learn how to seamlessly speak the language of these models. And no, it's not just smashing keys into a chat box. You've got to understand tokens, which are essentially the syllables and words the AI thinks in, and how to manage your context window. Think of techniques like zero shot as asking the AI to guess blind, whereas few shot guides it with a handful of really clear examples. Then you've got power moves like chain of thought, which is literally asking the AI to show its math and explain its reasoning step by step so it doesn't hallucinate. And ultimately, react, which combines that reasoning with taking actual actions. Mastering these elements, totally non-negotiable for an AI engineer. To actually put those prompting skills to work, you're going to be communicating with 2 very distinct ecosystems. On one side, we have the proprietary giants, right? OpenAI with their GPT and O series, Anthropic's Claude and Google Gemini. These are your heavy lifters. But on the other side is the wildly accelerating open source world, hosted on platforms like Hugging Face, featuring these incredible powerhouses like Meta's Llama, Mistral, and Cohere. As an engineer, the real skill isn't just knowing these exist. It's knowing exactly when to use a massive, expensive, closed model for complex reasoning and when a cheaper, private, open source model is just a much better tool for the job. All right, on to phase 3, memory, vectors, and RAG. Basically, this is all about giving the AI a brain. By default, large language models kind of have amnesia. They only know what they were trained on up to a certain cutoff date. So to fix this, we use embeddings. Think of an embedding like a giant multi-dimensional map. It takes human knowledge, like a massive PDF, a textbook, or your company's internal database, and translates it into mathematical coordinates. Concepts that are similar end up close together on this map, which allows the AI to instantly find and understand them. We then store all these numbers in specialized, highly efficient databases called vector databases, like Chroma, Pinecone, or Weaviate. And all of this builds into one of the absolute most important concepts in AI today, RAG, or Retrieval Augmented Generation. Let's walk through it step by step. First, you chunk your massive dataset into bite-sized paragraphs because, well, you can't just feed a whole book to the AI at once. Second, you embed those pieces into that numerical map we just talked about. Third, you store them securely in your vector database. Then, the real magic happens. During the retrieval process, when a user asks a specific question, the system instantly searches the database for the most relevant chunks of data. Finally, generation. You feed those retrieved, super specific facts directly to the LLM. You're essentially giving the AI an open book test, making sure it generates an accurate, highly customized answer based on your specific data rather than just taking a wild guess. Which brings us nicely to phase 4, action, building AI agents. This is where AI goes from merely thinking about things to actually doing them. Look, generating text is great, But an AI that can actually execute tasks, like booking a flight, updating a live database, or writing and running its own code, that is the holy grail of this field. AI agents achieve this massive leap through something called function calling. Using frameworks like LangChain, Llama Index, or OpenAI's Agent Kit, you aren't just giving the AI information anymore, you're handing it digital tools and the autonomy to figure out exactly how to use them. You define the tools, give the agent a goal, and the AI literally reasons through the steps required to solve the problem completely on its own. And finally, we arrive at Phase 5, Multimodal AI and Safety. This is all about expanding the AI's senses and, crucially, putting up the guardrails. Because the future of AI applications isn't just text boxes, it's multimodal. You're going to be combining powerful APIs so your applications can truly interact with the physical world. We're talking about integrating OpenAI Vision so your app can seamlessly see and analyze photos, using Whisper for flawless speech-to-text translation in real time, or generating dynamic images on the fly. You are literally building digital senses for your applications. It allows end users to talk, show, and interact with AI exactly as they would with another human being. But with all this incredible capability comes an immense responsibility: AI safety and ethics. It's actually shockingly easy to build a fragile AI app that can be misused. As an engineer, you have a real obligation to build systems that are robust and safe. This means actively trying to break your own systems through adversarial testing before anyone else does. You have to anticipate malicious prompt injection attacks, where bad actors try to trick the AI into ignoring instructions or leaking sensitive data. It requires implementing strict guardrails, bias checks, and rigorous content moderation APIs to protect your users and ensure the tech is deployed fairly and securely. So we've gone from the core definition of the role, through the foundational skills of prompting, giving the AI memory, giving it hands to take action, and expanding its senses, all while ensuring it remains safe. The roadmap to 2026 is fully laid out right in front of you, and platforms are already offering dedicated courses to help you get there. The tools have honestly never been more accessible, and the demand for builders has never been higher. So I guess the only question left is, are you ready to start building?